Welcome to AskPrep, your trusted companion for NEET and JEE preparation. Today we will study about a very important topic of chemistry, which is hydrogen bonding, influence on boiling point and solubility. This is a concept that often shows up in NEET and JEE exams, so stay tuned and follow along closely. Let's start by understanding what hydrogen bonding actually is. When a hydrogen atom is bonded to a highly electronegative atom like fluorine, oxygen, or nitrogen, the bond becomes polar. Since hydrogen has a partial positive charge and the electronegative atom has a partial negative charge, this leads to a type of interaction known as hydrogen bonding. Although this bond is weaker than covalent and ionic bonds, it is significantly stronger than other intermolecular forces like van der Waals forces. Hydrogen bonding occurs when the partially positive hydrogen atom is attracted to the lone pairs of electrons on a nearby electronegative atom. This attraction forms a kind of bridge between molecules, holding them together more tightly. As a result, substances that exhibit hydrogen bonding often behave quite differently compared to those that do not. One of the key effects of hydrogen bonding is on the boiling point of a substance. Boiling occurs when molecules gain enough energy to overcome the intermolecular forces holding them together and transition from the liquid phase to the gaseous phase. Since hydrogen bonds are relatively strong, they require more energy to break. This means that compounds with hydrogen bonding tend to have much higher boiling points than similar compounds where hydrogen bonding is absent. Take water, HO, as an example. Water molecules form extensive hydrogen bonding networks because each oxygen atom can form hydrogen bonds with two other hydrogen atoms from neighboring molecules. This creates a highly interconnected system that requires a lot of energy to break apart. As a result, water has a boiling point of 100 degrees Celsius, which is significantly higher than other molecules with similar molecular weights, like methane, CH, which boils at -161 degrees Celsius. Another great example is alcohols. Ethanol, CHO, exhibits hydrogen bonding due to the presence of the hydroxyl group, O. This hydrogen bonding increases ethanol's boiling point to 78 degrees Celsius, which is much higher than that of ethane, CH, a nonpolar hydrocarbon with a boiling point of -89 degrees Celsius. The strength of hydrogen bonding is also reflected in the trend observed across homologous series. As the size of the molecule increases and the hydrogen bonding sites become less prominent compared to the hydrophobic part of the molecule, the boiling point tends to decrease gradually. However, in smaller molecules where hydrogen bonding dominates, the boiling point remains relatively high. Now, let's shift our focus to how hydrogen bonding affects solubility. Solubility is often explained using the phrase, like dissolves like, meaning polar substances dissolve well in polar solvents and nonpolar substances dissolve in nonpolar solvents. Since hydrogen bonding contributes to a substance's polarity, compounds capable of forming hydrogen bonds often dissolve well in polar solvents like water. For instance, alcohols and carboxylic acids, both of which have hydroxyl groups capable of forming hydrogen bonds, dissolve easily in water. Methanol, CHO, and ethanol, CHO, being small molecules, mix completely with water due to the strong hydrogen bonding interactions between the molecules of the alcohol and water. However, as the length of the carbon chain increases in alcohols, the hydrophobic part starts dominating, making the molecule less soluble in water. That's why pentanol, CHO, is much less soluble than methanol or ethanol. Similarly, carboxylic acids like acetic acid, CHQ, dissolve readily in water due to their ability to form hydrogen bonds. However, as the carbon chain length increases, the solubility decreases because the hydrophobic tail outweighs the polar carboxyl group's ability to hydrogen bond with water. Another category where hydrogen bonding affects solubility is amines. Primary and secondary amines form hydrogen bonds with water molecules, making them soluble. However, tertiary amines, where all the hydrogens are replaced by alkyl groups, do not participate in hydrogen bonding as easily, resulting in lower solubility. Hydrogen bonding not only affects the solubility of organic compounds but also explains the behavior of biological molecules like proteins and DNA. In proteins, hydrogen bonds play a crucial role in maintaining the structure of alpha helices and beta sheets, while in DNA, the hydrogen bonds between nitrogenous bases hold the double helix together. Now, let's look at some exceptions and unique cases. Although hydrogen bonding is most commonly associated with oxygen, nitrogen, and fluorine, there are situations where the presence of these atoms does not necessarily result in hydrogen bonding. For example, hydrochloric acid, HCl, does not exhibit hydrogen bonding despite the presence of hydrogen and chlorine. This is because chlorine is larger and less electronegative compared to nitrogen and oxygen, making its lone pairs less effective at forming hydrogen bonds. Another interesting example is ammonia, NH. Ammonia can form hydrogen bonds, but its boiling point is much lower than that of water. This happens because nitrogen is less electronegative than oxygen, which makes the hydrogen bonding in ammonia weaker compared to water. As a result, ammonia boils at -33 degrees Celsius, much lower than water's boiling point of 100 degrees Celsius. In conclusion, hydrogen bonding significantly influences both the boiling point and solubility of substances. Strong hydrogen bonds increase the boiling point by requiring more energy to break the interactions between molecules. Similarly, the ability to form hydrogen bonds enhances solubility in polar solvents like water, although the effect decreases as the hydrophobic portion of the molecule increases. These concepts are fundamental to understanding chemical behavior, and mastering them will give you a solid edge in your exam preparations. Thank you. That's it for today's session on hydrogen bonding. I hope this discussion helped you grasp the concept clearly. Don't forget to stay tuned for more detailed and high-yield chemistry content, only here on AskPrep. We hope this video has helped you gain a clearer understanding of hydrogen and its compounds, especially the fascinating role of heavy water and isotopes. If you found this video helpful, make sure to like, share, and subscribe to AskPrep for more in-depth chemistry lessons. Keep studying, stay curious, and good luck with your exams.